Hello everyone, my name is Lance Andres Sambilio, and this is my video presentation about our presentation in a parent subject. Our topic for today is test benches in HTL, and the first thing that I would like to discuss would be generating manual stimulus. When we say manual stimulus, it is a way or it is a process on inserting new values to some of data inputs that you have inserted in your test bench manual. So in this video, I'm going to show you how to apply this thing in a simple combinational logic circuit. And since we are only focusing on test bench module, I already have created a design module in advance so that we could save up some time. And so that this video is a little bit short and it won't take long. So I have created a equation that we were going to solve, which is as you can see, the comment above, the y that is equals to a prime b prime that is multiplied into c plus ad and plus ab prime c. So into our design module, I have instantiated parameters with 4 inputs, which is the a, b, c, and d, and 1 output, which is y. I also wired different types of letters over here, which is the F, E, F, G, H, I, and J, which we're going to call them as nodes. And before we begin into our coding session, I would like to show you my truth table and then our logic circuit schematics that I have constructed earlier. My truth table shows the signals that our design module should have at the end of our program. I'm going to show an EP wave signal as an output so that we could refer to this kind of thing. And then I also have constructed a logic circuit schematic to visually interpret what does this equation have. And as you can see, we all have some letters in here, these are the nodes that I'm talking about. The E, F, G, H, I, J, and then the Y itself, which is the output of our equation. Wherein in this logic circuit schematic, we have used different types of logical gates, which is we have AND, the NAND, and then the NOT gate. So this is a simple combinational circuit that we're going to use anyway. So let's go by creating our module in test bench. So our module in test bench is, I'm going to call it tb underscore dsclc with parameters of registers of E, B, C, and then D, and then wire Y. And then the next thing that we need to do is to instantiate our design module into this thing by just calling the design module name that we have created, which is ds underscore clc. I'm going to name it as A1 and input some parameters in it, which is that A, that B as B, and then that C of C, and then that D or D, and D and Y, that Y, and Y. So upon instantiating our 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 design module into our test bench. This is where we're going to insert some values into our inputs, and this is where the manual stimulus comes in. Sorry for the interruption. I'm back. So the next thing that we need to do, just like what I've said earlier, is that the next thing that we need to do is to insert some values into our registered inputs, which is the A, B, C, and D. This is how you do it, which is we should initialize the data and then call them, which is A that is equals to 0, B is equals to 0, and then C is equals to 0, D is equals to 0. Now there are a lot of ways to do this thing, but this is how I'm going to do this. So I'm going to do this 16 more times. 3. Oh, I forgot about this. I got confused over there. So I'm sorry about that delay. Anyway, so this is how we do it, and then we just end the initial this one, and then we're going to start another one, which is initial begin, and this is where we're going to create a block to output our program, which is dump file from, I think it's test.vcd, and then dump bars 0, db clc, and then we're just going to do this thing 16 times because we have 16, and then we're just going to end this thing as well and end the module. And if I believe so, we could just save this thing. Wait, let me indicate the, oh wait, okay, so in those simulators we have the cursor log. Let me just put the output file name here, which is test.vcd, and then save. Wait, I'm sorry, I'm back. May mga nangangaroling lang. Sorry for the interruption. So I just run my program and it seems like there's a problem. I already know what it is. Forgot to add a function over here which is finishes the program. And if we save that thing and then just run it, I think it would be fine. I hope. There you go. So we have the EP wave, and let's get the signals from E1, and then let's just append them all. And as you can see, this is the output of our test bench. This is the output of our design module that we have created. the design that we have created. And to say that if it's right, we could refer to our truth table in here. In our y, just like in our y, we have 0 0 1 1 0 0 1 1 0 1 1 0 0 0 0, which is in our truth table. Our y is 0 0 1 1 0 0 1 1 0 1 1 1 0 0 0 0. I think I forgot 1 over here earlier, so I'm sorry about that. But hey, this is our it means that our design module that we have created is working fine. That's all for now. Thank you for and have a nice day.